Before we start, we have a little spoiler wall / disclaimer. First, I do not own any of the materials shown here other than my work, which you can tell obviously because it's handwriting. And also, I highly recommend you guys to do as much as you can on your own first so that you guys can make sure you're learning, then come here when you're either stuck so that you can get help, or to confirm your answers when you're done. Also, of course, never trust anything that you see on the internet, especially if it's like, someone random on the internet that you're watching, like me, or even the mark scheme actually, because in this case it was actually wrong. Always listen to your own knowledge because it's probably the most accurate. Alright then, let's get into the lab. So this lab is on the hydrochloric acid / borax titration and dilution. If you guys don't remember what it is, here it is. And without further ado, let's get into what I did. Now, unfortunately, I wasn't able to find a titration video on the borax / hydrochloric acid titration, but, if you guys don't remember it, hopefully you guys can figure it out through your lab sheets. If not, well, hopefully looking through this video will help you. So if you guys don't remember, the first thing that we did was we created diluted hydrochloric acid, 250 centimeters cubed, aka 250 milliliters, and then we just took a rough titration, essentially. For us, I had an initial reading of 0.45, and then our final reading was 26.25, and that yielded about 25.8. The actual value is probably going to be around 25.1-ish, so hopefully you guys got a rough titer within ±1 of that. And then for the initial reading and final reading for the actual titrations, I started again with our first trial, 0.45, and then for the final reading for that trial, 25.75, which made the net FP3 used as 25.3 centimeters cubed. For the second trial, you guys can see the values, of course. So the second trial, we did 25.1, and then the last one, we did 25.05. So obviously that first one is kind of out because it's not really within ±0.05 of our other reading. So we just ignore that one, and then for us we just did the 25.10 and the 25.05, which gave us a average titer of 25.08, which is how we got that value for the first question. Now, once you have your recorded once you record all your values, you'll be able to find your calculations. So let's start with CI. So you know that they gave you that the concentration of hydrochloric acid is 2 moles per decimeter to the negative third power. And that will basically mean that, as you can see in my calculations, I basically said that I just put the concentration down, so 2 moles over a decimeter cubed. And then remember how for our 250 centimeter cubed dilute hydrochloric acid, we put in 10 centimeters cubed of hydrochloric acid itself? That means that we're going to have 2 times 10. So we're going to have 20 moles times centimeters cubed of hydrochloric acid in there. And of course, we're going to have to divide that by 250 because 240 of that is actually diluted water, right? So we're just going to divide that up. And then, of course, we have to convert the decimeters cubed to centimeters cubed, and that would give you an 8 times 10 to the negative fifth moles per centimeters cubed of HCl. And then, of course, you would just multiply that by the value that you got for your accurate titer, which is in obviously part B. And that will give you, for us at least, 8 times 10 to the negative fifth times 25.08, which was about 2.006 times 10 to the negative third moles of HCl. Always make sure here you want to go to 4 sig figs because that 25.08 is rounded to 4 sig figs, but if you use 3, then you would go with 3. And then for part CII, they said 1 mole of borax is neutralized by 2 moles of hydrochloric acid. So of course what you want to do there is you can simply just do a conversion. We used 1 mole of borax for every 2 moles of HCl, and then you can see the conversion that I did there. And then basically it's just what you got for part CI divided by 2, and that would give you 1.003 times 10 to the negative third moles of borax. Of course, you're probably not going to have the same answer if you had a different accurate titer. So again, just make sure you do everything properly there. And then for CII, we have use your answer to II to calculate the number of moles of borax in 1 decimeter cubed of FB1. So first things first, we have to make sure how much FB1 we used, which was 25 centimeters cubed. And then we just divide that value that we got just now, which was, in my case, 1.003 times 10 to the negative third, divided by 25. And of course, unit conversions, since they asked you for decimeters cubed. And that would give you 4.012 times 10 to the negative 2 moles of borax per decimeter cubed, for our group at least. And then, of course, they asked for 1 decimeter cubed of it, so you would just multiply it by 1, and that just gives you 4.012 times 10 to the negative 2 moles of borax in 1 decimeter cubed of FB1. And then they're saying use your answer to III and the information on page 2 to calculate the relative formula mass of borax. So what you want to do here is on page 2, they gave you that the molarity of borax here is 15.5 grams per decimeter cubed. So obviously you use a conversion rate. So we have 15.5 grams per decimeter cubed, right? And then we multiply it by decimeter cubed over 4.012 times 10 to the negative 2, which is what I did for the previous part. And then that ends up being 386. And that is how I got my molarity of borax. Of course, you want to write your units, and remember, ACE likes to write it in exponents, so instead of saying per mole to the negative, like per mole, write it as mole to the negative first power. Then for CV, we're just finding X. So what you want to do here is they gave you the molarity for borax, and you want to take out all of that Na2O7, and you also want to take out that 10H2O. That way you're left with nothing but the molarity of borax here, which is Bx in this case. So you guys can see my work there, and then that ended up giving you all that. And then, of course, you need the molarity of boron on its own, which is 10.8, according to ACE periodic table. So you would do the molarity of borax minus 180, which was the molarity of 10H2O, minus 158, which is the molarity of Na2O7. And then, obviously, 386 is the molarity of the borax that we got. And then divide all that by the molarity of boron, 10.8, which gives you 4.44, round that, and you get X equals 4. And that is all my work there. Now, to confirm whether X is really 4, it's actually really easy. Just go to Google and then start looking up all the B values that could possibly not be 4. Like, for instance, just Google 3, 4, and 5. So what I did was, as you can see on the screen here, Na2B307, and then I looked up Na2B407, and then Na2B507, obviously with the 10H2O attached to that, and then the only one that actually yielded proper results is Na2B407 times 10H2O, which kind of shows that we are good here. And then, of course, here's the actual balanced chemical equation for this. So it's obviously borax plus hydrogen chloride is equal to boric acid plus sodium chloride plus water, and then you can see the balanced values there. So we have that borax equation, and then we have 2HCl, which gives 4H3BO3, and then 2NaCl plus 5H2O. And that is our balanced equation. So obviously, since we have that, you can either take my word for it, or just find it yourself. I think this shows that we are pretty good to go. Now that we're done with my work, let's go take a look at the mark scheme. So to do this, you can look at the bottom of the paper, and you guys can see over here that it says 970134MJ16. So all you have to do is Google that, 970134MJ16, and then that will give you a Google search, obviously, and then click on the first few links, preferably the first link. That's typically the one that you want to go for, and then obviously, as you can see on the screen here, you have the mark scheme. Now, for YouTube video purposes, I purposely put that onto a separate document so that we can look at it together a lot more easier. And you guys will notice that the first thing that kind of pops up is, how to do the tables. And this is kind of similar to what Mr. Dilworth showed us throughout all the other mark schemes in class. This constantly stays the same, and this won't really change. So once you get this mastered, you're pretty much set for the first 7 points. Now, when we go on to part CI, you guys will notice something really weird. You'll see that instead of like the weird calculation that I did, they just put 0.008. Now, that is actually wrong. The correct answer would be 0.08, not 0.008. If you had done 0.008, you would have gotten 10 to the negative 4th instead of 10 to the negative 3rd, and then that would give you a chain reaction, as you guys can see on the screen here. And then you will get that borax's molarity is 3,860, which is obviously not what it's supposed to be. And if you guys just want to double check if your actual molarity is proper, here, you can also do a Google search on what borax's relative mass is. And here we see that borax's molarity is 381.37, which is awfully close to the 386 that I got. So obviously that is nowhere near 3,860, so you can tell that the mark scheme here was wrong. And like I said, never trust everything that you see on the internet, because even the rubric could be wrong. Anyways, moving onwards, you guys can see that you can kind of look through the Cambridge rubric. They condense a lot of the work, and they'll still give you the point if you just do that, but I wouldn't recommend just copying off the mark scheme, because teachers will obviously see that you condensed a lot of the work. For instance, notice how they wrote for CIII, your answer to part II multiplied by 40. Well, that's actually 1,000 over 25. And you would have to show the conversion for your teacher to kind of believe that you did the work on your own, because they're going to be wondering, well, how did you get the 40? So I would recommend showing your work before just copying the answer key just word for word. It's not a good idea, and people will let me just tell you something. Mr. Watts, our physics teacher, will tell you that they actually make the mark scheme so that if you copy the mark scheme exactly, there are going to be like mistakes that you will like blatantly show, and that the test grader will immediately know that you cheated. So I wouldn't recommend copying this word for word. Figure out how to get everything, or as always, just watch my YouTube videos and I will explain everything for you. And that concludes our Borax hydrochloric acid lab. Hopefully you guys made sense of that. If not, always just drop down a question in the comment section. That's what it's there for. Questions, comments, concerns. And if you guys ever see a comment asking for help, please just reply. It's a good thing. You'll feel happy for yourself, and the person who receives that help will be very grateful as well. So anyways, hope you guys enjoyed. I'll see you guys next time. Goodbye!